In this video, we will look at solving absolute value inequalities. So first example, we have absolute value of x minus 2 is greater than or equal to 4. So that means we have a number whose absolute value is greater than or equal to 4. There's two places a number can be at. All the numbers to the right of positive 4 have absolute value greater than 4 or equal to 4. And all the numbers to the left of negative 4 also have the absolute value greater than or equal to 4. So that means I can split this into two equations. Either x minus 2 is greater than or equal to positive 4, or x minus 2 is less than or equal to negative 4. Solving both individually, x greater than or equal to 6, or x less than or equal to negative 6. So that means my solution is going to be two different intervals. I can have either negative infinity to negative 6, union 6 to infinity. So because all the numbers from here onwards and here onwards are my solutions, they are part of my solutions. And because we have the equal sign, I'm going to go back, make a correction. There is going to be the 6 and negative 6 will be included because x greater than or equal to 6. If I did not have the equal sign, we would use parentheses, but because there's an equal sign, we would use brackets. Let's see another example. First, I'm going to isolate the absolute value symbol. Absolute value of 2x minus 5 is less than, absolute value of 2x minus 7 is less than 5. So absolute value of a number is less than 5. That means that number can lie in here. That number lies between negative 5 and 5. So I can write it in a nested way. Remember, less is nest, more is or. The less ones, we can write them in a compact way. I can say that this number lies between negative 5 to positive 5, between negative 5 and positive 5. 2x minus 7 lies between negative 5 and positive 5. Now let's go ahead and solve it. So add 7. That gives me 2 less than 2x less than 12. Divide everything by 2. X less than, when we divide everything by 2, we get x lies between 1 and 6. Now to write it in the interval notation, my solution lies between 1 and 6, and both will have the parentheses around, no brackets. See another example. Here's the more symbol. Remember, more is or. When absolute value is more, it's going to be an actually or problem. Think about what's happening here. We have a number whose absolute value is greater than or equal to 6. That means the number can lie over there, or the number can lie to the left of negative 6. So 4x minus 5 can be greater than 6, or 4x minus 5 can be less than or equal to negative 6. Let's go ahead and simplify it, solve it. X greater than 11 fourths, or 4x less than equals negative 6 plus 5 is negative 1, x less than equals negative 1/4. So that means my solution will be negative infinity to negative 1/4, again with the bracket, and then 11/4 to infinity. Okay. All the numbers to the right of 11/4 are okay, and this will also have an equal sign, so there will be a bracket here as well, because we did have an equal sign in the problem. Another example, 9 minus 2, absolute value of 4x plus 7, 4x plus 1 greater than 3. And keep in mind, here, you don't want to do 9 minus 2 first, because you're now following order of operations. That negative 2 is actually multiplied with the absolute value symbol. So don't subtract 2 from the 9 and make it a 7. That would be not okay, because that way we are not following the not following the order of operations. First step is to isolate the absolute value symbol. So I'm going to subtract 9 from both sides. And that leaves me with 3 minus 9. is going to be negative 6. Now, next step is to go ahead and divide both sides with negative 2. Remember, when we divide with negative 2, we're going to flip the sign. When we divide an inequality with a negative number, the sign of inequality flips. So negative 6 divided by negative 2 is positive 3. Absolute value of this number is less than 3. That means that number can lie anywhere in this zone. So I'm going to write it in a compact way. That number 4x plus 1 lies between negative 3 and positive 3. Subtract 1 from each side. Negative 4 less than 4x less than 2. Divide everything with the 4, and that's going to leave me with 4, divide with the 4, divide with the 4. Negative 1 less than x less than 1/2. So my solution in this case is negative 1 to 1/2. All the numbers between negative 1 to 1/2, not including negative 1 and 1/2, will make this inequality true. So for absolute value inequalities, remember to draw the number line and see what's happening, and then set up your next equation or next two equations.